Hello and welcome everyone to the making of the coronavirus data art project that I published last month. This project was a very personal project to me. Let me just show you how it looked like. So here, when you go to my website higgs.com, you find the mutant waves of London at the very top because it's my most recent side project that I published here on the web page. Now when we go to the page, you can first see that I used Node and D3.js to produce these viral mutant waves. I also used some Affinity Designer for the final polishing of the static poster piece. When we go through it, I produced for each of the main variants of the coronavirus that have been spread in London, UK, these waves here. And actually these waves are not just randomly drawn curves or something like that. They are based on the geographical shape of London. We go to the final poster that you can see here. You see that for the B117 mutant, which is at the moment rising extremely here in Germany, we see that it had its peak already in the UK. And you can see that the curve shape, the wave shape, is basically based on the shape of London, which is just plotted again and again and again. Today I want to show you how I built these shapes, these waves within D3.js and Node.js. But before we start, let's have a closer look on these shapes so that you can understand a little bit better how they are produced. Let me switch to a representation where I plotted one of these shapes with a less resolution basically. And here you can see that we have here a very large shape of the geometry of London. And then this is plotted and plotted and plotted again. And it's just changed in the size and it also changed in position. And this in total gives this nice flowing effect. And here it's just a bad resolution. When I add more and more of these shapes, when I interpolate in between of these shapes that you see here now, then you come to the full picture that we see in the poster here. And this is also true for the other mutants here, but there you cannot really see that it's the shape of London because after they reached their peak, they were going down again. So the abundance of these coronavirus variants was going down again, close to zero, because the B117 mutant really pushed all the other mutants away. Alright, so how did I build that? Basically the question is how to implement D3 code within Node, because usually you might have used D3 in a browser setting where you just import D3 to your web project and then you're plotting something directly to the screen. But here I wanted to produce just PNGs or maybe JPEGs that had these flows inside. Now I switch over to the coding project here. And when I build something which is offline, which is not running within the browser, I usually have this structure of my directories. So the main flow is happening here in the index.js file. The index.js really has all the commands like loading the data, defining my scales, selecting the variants I want to plot, and then also the plotting and exporting itself. But that's just the superficial structure of the whole application. All the nitty-gritty details about the plotting, they are more or less hidden within my utils directory, where I collect functions that have something to do with the canvas itself, because we're drawing on a canvas here, with in and output operations, or with scales. I also have a file that I always use, which is a config.js file, and I want to start with that actually. The config.js file is just a JavaScript object, and that JavaScript object has some properties like the mutant data path. So where did I store my data? Where did I store my shape path? Because the London shape, of course, is kind of GeoJSON that I use. Then I can select also variants that I want to plot. So here I just selected one of the variants right now. And then I also set width, height, background color, fill color, last fill color, which is this final color, which is on the shape of London, and so on and so on. So I have all these different settings that I want to modify during the design by coding process in this one file. And so it's very easy for me to just switch around the numbers, exchange numbers, increase things, omit things, and so on. So as I said, the main code is running within index.js. That is the superficial structure of my project. And here you see that I just import this config object. So within the config variable, I now all have these settings that I set in the config.js files. Then I also import the functions I need from my canvas utilities, from my in and output utilities, and from my scales. And I also have an extra file with some colors, which are the different variant colors. So the colors of the flows that we see later on. I have them here extra in this color.js because that was quite a bit, and I wanted to keep them separately from each other. So back to the index.js, I then always have this immediately executed function, and I do that because I want to use the async await syntax also on the top level of my program. However, in Node, this is not possible yet. It might come. But if you want to do that, you need to wrap all the functions within an anonymous function here that you put to async. Actually, it's not anonymous at all here. It's called main. And if we go to the very bottom, we see that this function is immediately executed. So, and then I start with reading in the data. So here I load the data, which is done by calling the function load mutant data. And if we go to that data, which is stored here, we see that there is a date, there is a region, and we were only interested in the London region. Here is the mutant name, and here is the relative abundance of that mutant at the specific date. That's everything. I just load that, I filter it for the London NHS region, and then we continue. So we have the data here, and then I also load the shape, which is just a GeoJSON of the London geographic shape. When I have the data, I'm able to also define my scales. I have an X and a Y scale, which is apparently the scale across the X-axis and across the Y-axis, and I also have an R scale. R standing for radius here. It's basically the size, the diagonal size of the London map that I use. I used radius here because in the very beginning of that project there was the London shape not involved yet, so I had just some circles to play around, and that's why I have the radius here. And within the function define scales, I put the data in, and also the width and the height of my final canvas that I want to have. And this is then these scales are defined, and this is just simple D3 scales. And if you like, we can just go to that. So let's open that here. Oh no, I have to click here. Sometimes that works, sometimes not, but doesn't matter. So here we see the define scales function, and here you can see this is just scale linear for the radius, which is not really the radius, and also scale linear scales for X and Y scale, and then I just return them. And within my index.js, I destructure them to have them in separate variables again. Okay, then we are selecting the variants. So here, with the help of my config.variance selection, I just put all the variants I want to plot within that variance variable, and then I run through that variance while being variant just the actual variant that we want to plot. There's some console log. And then this is very similar to what happens in the browser. So we first want to create a canvas. For that, I created that function init.canvas. Takes the width and the height of our final desired canvas, and also a background color if we want to have one. And then it creates a canvas, and it also creates the context of the canvas. And I can now work with these two variables to create our picture. Then I also pull the colors for that specific variant from our variant colors file. And if the variant is B, I also first plot some marks on the X and Y scale so that I can later, when I work with that specific variant, I can see where, for example, the dates are and how the Y-axis relates to the actual values. That is actually not really important, and I will cut it out for now. Because the most important step here is this plot flow function, and this is an important function not only because it takes a lot of parameters. This is of course the main plotting thing happening, and this is what I want to look a little bit closer with you. The plot flow function is located in the canvas.js file because it's a canvas function. It draws to the canvas. Let me just see, here it is. The plot flow, it takes a lot of different variables, for example also the context of our canvas, otherwise we could not draw to the canvas, also the data and the shape and all the different scales and all that stuff. And what I usually do is when I plot something on canvas, I save the current settings of the context and restore them when I'm done with my plotting stuff. Otherwise, sometimes you observe very weird bugs while, in your canvas plotting procedure, and that's sometimes you change here settings that you don't change back again, and so this is a very safe way to do it. Then I set some global stuff like the opacity of my drawings, the line width, the fill style, and so on. And then I first get a projection. I need the projection to turn my GeoJSON file into actual SVG paths, and these SVG paths are then used to produce the drawing line on the canvas, because we are not using SVG. Then we run through the data, and we run through it for each data point, and each data point is basically a date where the mutant abundance was measured or predicted. And I calculate then the coordinates for the current data point, and I also calculate the coordinates for the next data point. The coordinates really means where on my canvas should I plot now a single map of London, so where in terms of X and Y axis, and also how big should that London be. And I calculate the current and the next data point because I want to interpolate a little bit between these 2 points to produce even more London shapes, so that then you get this real flow behavior. And this is done again within a subfunction which is draw segment. And if I go to draw segment, which should be here above, this is draw segment. There is some interpolation going on, so I run through different iterations. So for example, I have a starting shape and an end shape, which is the current and the next data point, and then I can extrapolate the number of iterations, shapes between those 2 points, and this is what's happening here. And then here is the geopath calculated. This is also D3 function, which takes your canvas context, which takes your projection of the London map, and then is able to draw that actually to the canvas, which is happening here when I call that gpath function that I create here. And that's basically it. And then London is plotted and plotted and plotted all over again. And now let's see how that actually works. Well, the plotting has been done when we go back to the index.js, but I have another function which is also important. Otherwise, this image that we produce now in memory would not be exported. So I have an export to image function, which is just some a collection of some Node.js functionalities to take that canvas and to output it as a PNG or a JPEG, depending on what you have set in the config.js. So this is how it's going, and this is then done by all the variants that we have specified. And now let's go back to the config.js, and you see that we have here a parameter which is called iterations. And when iterations is set to 1, then really I only plot the London shapes at the data points that were actually measured without any interpolation in between. And this is what we are going to start with now. So I show you on my second screen my console, and I'm already in the right folder. And what I can do now is I can, with npm run dev, I can start nodemon, and nodemon is an executor for Node, which is a little bit like a live server, so it's restarting all the time when we change something in the code. So that's pretty handy for the process of generating different designs over and over again, exactly when you are in this process of designing by code. And we can see there was this process now selected, so not the variant selected, VOC something something, that is the bad mutant, the B117. This is how it's called in Germany at least. And when we go to the output again, this is what has been created. You've seen that before, and you can see the resolution is not very good, and this is because I only have this one iteration of the data points. And now when we go back to our config file, I could set the iterations maybe to 5. And then I save that, and when I switch back to my terminal, you see that it's running again because it detected there was a change in the code. And this takes now a little bit longer because we have 5 times more iterations that we need to plot. And this is computationally actually heavy to plot these shapes on the canvas. It's also a little bit heavy to rescale our projection of London all the time, depending on the different diameters that I want. So let's see what happens here. And yeah, you can imagine that when I was in development mode, I only took one iteration all the time because it made it quite easy to change everything. But now we are done, and we see we have an image which has been output. So let's see, and this is the result. And now you can see it looks a bit more like flowing curves now, because there is much more London shapes produced right now. And this actually already looks really nice. It has some bad interference effects here at the boundaries maybe, but it's nice. This was 5 iterations now. For the final poster, I went with 13 iterations. I can't remember how I actually set that number, but it just looked good. So when I put that to 13 iterations, it really looks like a nice flow. And when you go over 13, it gets too dense actually. But with that, I produced then all these different flows for all the different mutants. Let me go back to my web page. Here you see the final poster. This here below is the mutant that we just created, but with 13 iterations. And here also with 13 iterations are all the other different mutants. And of course, there are different colors involved. And it's really nice, this effect. And I just want to highlight that I'm a fan of Dan Grease here. He has a lot of examples how to use that. Not with geometric shapes or with geographic shapes actually, but with other stuff, using some noise algorithms and all that. Really nice. Check out his stuff, definitely. But yeah, that is the data art poster that I created, and I hope to show people with that how severe this B117 variant is, how it really has eradicated all the other mutants in London, and this is what's going to happen in Germany, in other parts of the world now, or has already happened. And of course we hope that there might not be too many other worse mutants coming up. Yeah, but that was my take on the coronavirus scientific data, and I hope you liked it. You can always visit my website at higsh.com, and check out the project. And of course, also the code for this project is publicly available, so you can download it from GitHub. Link is also here on this webpage. You can download it and have a look. And yeah, if you modify it and produce some new nice flows, put it on Twitter, send it to me. I'm really interested what you will make out of that. And with that, thank you for walking with me through this very nice coding project that I did at some point in the evening during February. I learned a lot again with that, because I never did this kind of shapes and curves and flows before. And these side projects are perfect to improve your skills in a coding language, for example, and also in a design language. So I really encourage you to also do some side projects. That's really cool. Thank you all. Stay healthy and see you soon. Bye.